Hi, I'm Bob Helsel from the IVI Foundation. Welcome to the IVI Getting Started Guide videos. Our purpose is to provide you with an easy tutorial on using IVI drivers in the development environment of your choice. After a brief introduction, a technical expert will show you how to use drivers with your ADE. First, I'd like to go over a few key benefits in using IVI drivers. They will save you time in your program development. Number one is interchangeability. IVI drivers enable the exchange of instruments in your system with minimal code changes, reducing time and effort. Two, ease of use. You can use your favorite ADE such as Visual Basic, Visual C++, LabVIEW, LabWindows, MATLAB, or V. The standard APIs provide fast, intuitive access to functions. Three is quality. You'll have common commands and desirable options. The Foundation's rigorous testing ensures driver quality. Four is simulation. Simulation allows code development and testing even when an instrument is unavailable. We'll be taking advantage of the IVI simulation feature as not all viewers will have this hardware available. Fifth is performance and reliability. Examples of these are capabilities such as range checking and state caching. These are some of the key features of IVI drivers that will cut your program development time. In order to follow along with this tutorial, you'll first need to download and install an IVI driver. There are two ways to do that. You can go to the driver registry page on the IVI website, or you can go to the instrument vendor's website. Find the 34401A driver, download and install it before taking the tutorial. Now let's go to the product expert for your ADE.
Hello, and welcome to the IVI Getting Started Guide for LabVIEW. My name is Lars Lindstrom from National Instruments. LabVIEW is a graphical programming environment that makes it easy to control and acquire data from any instrument over any bus. You can automate measurements from several devices using instrument drivers, analyze data as you acquire it, and create custom reports. This tutorial will illustrate just how easy it is to use IV drivers in the LabVIEW environment. Now, in order to follow along with this demonstration, the minimum software required is listed here. For assistance finding and installing the software, just refer to the IVI Getting Started PDFs on the Resources page of the IVI Foundation website. To begin, we first need to open up LabVIEW by going to Start, All Programs, National Instruments, LabVIEW 2010. Once it loads, click Blank VI to begin developing. I'm first going to make use of my screen space by going to Window, Tile Up and Down, so I can see both my front panel and my block diagram on the same screen. Next, to find the functions that installed along with the IV driver, I'm going to go ahead and right-click anywhere on my block diagram to bring up the Functions palette. I'm going to go to Instrument I/O, Instrument Drivers, where I can then see any instrument drivers that have already been installed onto this machine. The 34401 palette on the left is the example LabVIEW plug-and-play driver that ships with the environment and is not the focus of this tutorial. The IV driver for the Agilent 34401A is the palette on the right, which I'm now going to pin down as I'm going to be using it for the rest of the example. The first thing that I'm going to need to communicate with my simulated DMM is to initialize my particular instrument. To do this, I'm first going to drop down the HP 34401A Initialize with Options VI. I'm then going to turn on Context Help and hover my mouse over the function, where you can then see all of the inputs and outputs for this particular VI. The first input that I'm going to wire is the resource name, which identifies which instrument I'm going to be talking with. To do this, I'm going to right-click on it and go to Create Constant. Now, as mentioned in the introduction, there are many advantages of IVI, including range checking, state caching, and instrument simulation. Since I don't happen to have this particular benchtop instrument next to me, I'm going to go ahead and take advantage of that last IVI feature by setting the simulate parameter from 0 to 1. To do this, I'll first create a constant by right-clicking on the option string input and go to Create Constant. I'll then change the parameter for simulate from 0 to 1. Now, one thing to note is that even though I don't have a specific instrument connected to this GPIB address, this doesn't actually matter, as I've set my simulate parameter to be on, which means that the IVI driver will automatically simulate an instrument at that location. Now that I've initialized my instrument, I can go ahead and start configuring a few of the settings that will be required to read from my simulated device. The first thing I'm going to do is I'm going to move my palette up here to give myself some room, and I'm going to use the configure. I'm going to do the configure measurement VI. I'm also going to go into the trigger section, and I'm going to drop down a configure trigger VI. And the next thing I need to do is actually read from my device. So I'm going to go up a few palettes. I'm going to go to the measurement section, and I'm going to drop down the read VI. And last but not least, I need to make sure to close out my session. So to do that, I'm going to drop down the close VI. And finally, I need to make sure to do error checking, so I'm going to drop down a simple error handler, which will check to make sure that there are no errors and display a dialog if there are any. Rather than spending the time wiring all of the inputs for the functions, I'm going to go ahead and open up my completed example. As you can see, I've already wired up the instrument handle between every single VI as well as the error wires. For the configure measurement VI, I've wired in a measurement function value of DC volts, and I've set the range to be 10, which means plus or minus 10 volts. For configure trigger, I've wired in a trigger delay of 0, which means it will be instantaneous. For the read VI, I've wired in a maximum timeout of 5,000 milliseconds. I've also created an indicator for the reading. This reading should display the simulated value every time it executes. Let me go ahead and run this so you can get an idea of how it works. As you can see, every time I run this, I get a new simulated value within the range that I set. Now, I built this example from scratch, but most of our IVI drivers do ship with examples to get you started. These can be found in LabVIEW by going to the Examples section, where you can now see that we have both a single point measurement and a multi-point measurement example that come with this driver. This concludes the IVI Getting Started guide for LabVIEW. I hope you've been able to see how easy it is to bring IVI drivers into the LabVIEW environment. For more information about LabVIEW, please go to www.ni.com/LabVIEW. For additional information, including videos, tutorials, and more documentation, you can go to the IVI Foundation website at www.ivfoundation.org. Thank you.